All right, so a couple of problems were asked about from 3.5. So continuous compound interest. So when we're doing the compounded continuously, um, there's the formula of the amount equals PE raised to the RT. So I'm going to bring up Desmos. We should just be able to input some of the values, but we just have to know what we are inputting. So on so on this one, if the initial amount is 2,000, I want to know time to double will be 4,000. So if we know this formula where the amount equals P E raised to the RT, right? We can figure out some of these values. So I'm going to come down here, and so our amount that we want to have is $4,000. And so our initial amount is $2,000. E is just a number. The rate is 6.6, so 0.066. And X is what we're solving for. So when we do this, we'll have to do this by hand. And because X will be our time in years, but this will be the formula that we're setting up, and I'll do a supplement to it. Amount after 10 years, well, we're just looking for A on this one, and so that second part, the amount after 10 years, we can solve right now and just put times 10 up top, and that's how much we'll have after 10 years. So I'll do a supplement for how to solve that second problem. But thinking about it, if we had this, here's would be a way we could solve it graphically. I want to know when this thing equals 4,000. So I have two equations. And talking about our substitution, elimination, and graphing, we could do a graphical approach to this one. We know that X is our years, so our years wouldn't be negative, so we could go from maybe 0 to 20. But again, when we start at 2,000, and we're trying to see when it gets to 4,000, and if we do that, we'll get an answer here. So X stands for the number of years, 10.502. Again, I'll show that one algebraically. Number 2 is similar, except they're asking you to solve for different things. So on number 2, we're still playing with this formula because it's compounded continuously. I don't know what my initial investment is or my rate, but I know after 10 years I have $2,500. So if we know A equals PE to the RT, so we know that, we would first figure out, using this time double, we could just make up numbers. Like, let's say I have $2,000 is what I have eventually. Let's say I started with $1,000. So we still have E raised to the rate, which I don't know, times T. Well, it's 14 years for it to double. And so we're solving for that rate right there. And so that's something that we can solve for as well. And then once we know that rate, it'll be easy just to plug in after 10 years how much would I have. Or if we plugged it in for 10 years and I had 2,500, it'd be easy to solve for P. And so I'll look at 2 on solving for number 2. And then the last one is number 4, and it has a slew of questions. But again, if we know this initial thing, right, we know that in 2008, so T would equal 8. So our T right there is 8. and the population was 359,000. So we would just type in a 359 there, because the P is in thousands. So once we have that set up, we'd be having 359 equals 314.4 e raised to the k is what we're solving for. And then the time was in 2008, so that would be 8 years. So in this one, we would just be solving for k. So I'll do one for the first part of number 1, the 2 parts for number 2, and that part for number 4.